Winds. The direction of these winds changes with the change of seasons. Monsoon winds are the most important periodic winds, e.g., land and sea breeze, mountain and valley breeze. 1. Land and sea breezes. Due to differential heating of land and water, a pressure gradient is created, causing sea breeze during day and land breeze during nights. Daytime, land heats up faster than the sea, pressure gradient is from the sea to the land. Nighttime, land loses heat faster than the sea, pressure gradient is from the land to the sea. 2. Mountain and valley breezes. Due to differential heating of mountains and valleys and radiational loss of heat from mountain slopes at night, a pressure gradient is created, causing valley breeze during day and mountain breeze during night. Daytime heating up of mountain slopes and high pressure in the valley. At night, as slopes cool, dense air descends into the valley. Atmospheric circulation and weather systems. 35. Local winds. Local differences in temperature and pressure produce local winds. Such winds are local in extent and are confined to the lowest levels of the troposphere. Cold winds. Z Pampero, a west or southwest wind in southern Argentina. Z Bora, cold, dry wind, blows from Hungary to North Italy. Z Mistral, very cold and dry with a high speed, channeled through the Rhine Valley. It brings blizzards into southern France. Warm winds. Z Lu, harmful and warm wind in the plains of northern India and Pakistan. Z Chinook, warm and beneficial wind, moves down the eastern slopes of the Rockies, USA and Canada. It is beneficial to ranchers east of the Rockies as it keeps the grasslands clear of snow during much of the winter. Z Sirocco, warm and harmful wind. A Mediterranean wind that comes from the Sahara and reaches hurricane speeds in North Africa and southern Europe. Causes dusty dry conditions along the northern coast of Africa, storms in the Mediterranean Sea and cool wet weather in Europe. Z Fain or Fen, hot and beneficial winds in Alps. A strong, gusty, dry and warm wind that develops on the leeward side of Alps. Helps animal grazing by melting snow and aids in ripening of grapes. Air masses. A large body of air having distinctive characteristics in terms of temperature and humidity with little horizontal variation. Air masses. Geographical classification. Tropical air masses T. Oceanic tropical air masses MT. Sea polar MP. Continental polar air masses CT. Continental polar CP. Warm, M, stable S, cold, C, unstable C, polar air masses P. Thermodynamic classification, mechanical classification. Source region. When air remains over a homogeneous area for a sufficiently long time, it acquires the characteristics of the area. These are known as source regions. Z, it imparts heat and moisture characteristics to the overlying air mass. Z, this can be the vast ocean surface or vast plains and plateaus. 36. Atmospheric circulation and weather systems. Z, there are no major source regions in the mid-latitudes as these regions are dominated by cyclonic and other disturbances. Types of air mass. Z, cold air mass which is colder than the underlying surface. E.g., air mass over Siberia is not cold for Siberia. This air mass might be cold air mass for the warmer regions down south. Z, warm air mass which is warmer than the underlying surface. E.g., air mass over Siberia might be warm air mass for the Arctic region. Air masses are classified on the basis of source regions as follows. Types of air masses. Air mass type, source region characteristics. Continental polar CP, cold, dry land areas cold and dry, frigid temperatures, low humidity. Continental tropical CT, hot, desert regions hot and dry, high temperatures, low humidity. Maritime polar MP, cold oceanic regions cool and moist, cool to cold temperatures, moisture. Maritime tropical MT, warm oceanic regions. Warm and humid, warm temperatures, higher humidity. Continental Arctic CA, polar regions extremely cold and very dry, bitterly cold, dry. Continental equatorial CE. Desert regions near the equator. Extremely hot and dry, scorching temperatures, low humidity. Fronts. Front is a three-dimensional boundary zone between two converging air masses with contrasting physical properties like temperature, humidity, etc. Z, commonly formed in the middle and higher latitudes, 40 to 65 degrees latitudes, where warm and moist subtropical air masses come in contact with cold and dry polar air masses. The process of formation of a front is known as frontogenesis and it involves convergence of two distinct air masses. Z, dissipation/weakening of the front is known as frontolysis, where one of the air masses overrides another. Z, in the northern hemisphere, frontogenesis happens in an anti-clockwise direction, clockwise in the southern hemisphere, due to Coriolis effect. Z, fronts are the reason for the formation of temperate cyclones in mid-latitudes. Types of fronts based on the mechanism of frontogenesis. Z, stationary front. Air masses are not moving against each other. Wind motion is parallel to the front. Z, cold front. Transition zone where an advancing cold dry air mass violently displaces a warm moist air mass. Cold air advances toward warm air, more steep. Cumulonimbus clouds are formed resulting in heavy rainfall. Thunderstorms and tornadoes E.G. in the USA are common features in warm sectors of cold front. Z warm front. Warm air advances toward cold air and makes a gradual front, less steep. Causes moderate to gentle precipitation over a large area. Z occluded front. When a cold air mass overtakes a warm air mass and goes underneath it. Warm air mass is lifted entirely off the land surface. Cyclones. A cyclone is a large-scale air mass rotating around a strong center of low atmospheric pressure. Cyclones can be classified on the basis of their origin into tropical and extratropical cyclones. Z wind circulation around a low-pressure system is called cyclonic circulation and around a high-pressure system is called anticyclonic circulation. Pressure system pressure condition at the center pattern of wind direction northern hemisphere southern hemisphere cyclone low anticlockwise clockwise anticyclone high clockwise anticlockwise. Atmospheric circulation and weather systems 37. Temperate cyclones. The low-pressure systems developing in the mid and high latitude, beyond the tropics are called the temperate/extratropical/mid-latitude/frontal/wave cyclones. Z most commonly formed at the polar fronts, where warm and moist air masses meet cold and dry air masses from poles. Z occur mostly in winter, late autumn, and spring. Z they stretch over large areas under the influence of westerlies. Z approach of a temperate cyclone is marked by fall in temperature and pressure and a thin veil of cirrus clouds. Z these cyclones move from west to east under the influence of westerlies. Z the western disturbances arriving in northwest India during winter are remnants of such cyclones. Process of formation. Z pressure drop along the polar front initiates an anti-clockwise cyclonic circulation. Z warm air from the south moves northward and cold air from the north moves southward. Z this circulation forms a well-developed extratropical cyclone with a warm and cold front. Z the cold air pushes the warm air upwards from underneath, resulting in cloud formation and precipitation ahead of the warm front. Z as the cold front displaces the warm air, occlusion occurs, leading to cyclone dissipation. Tropical cyclones. They are strong low-pressure centers that originate over oceans and tropical areas and move over to the coastal areas, bringing about large-scale destruction due to violent winds, very heavy rainfall, torrential rainfall, and storm surge. Z violent storms originate over oceans and tropical areas. Z compact size ranging from 80 to 2,000 kilometers in diameter. Z a roughly circular calm area of comparatively light winds and fair weather at the center is known as the eye of the cyclone. It has lowest surface pressure and warmest temperatures, and air descends at the center. The eye temperature may be 10 degrees Celsius warmer or more at an altitude of 12 kilometers than the surrounding environment, but only 0 to 2 degrees Celsius warmer at the surface in the tropical cyclone, UPSC 2020. Z eye is surrounded by the eye wall with strong spiraling ascent of air where winds blow the fastest, resulting in torrential rains. Z latent heat of evaporation released by the condensation of moist rising air over oceans is the driving engine for tropical cyclones. Z they dissipate after they make landfall because the latent heat of evaporation is not available, moisture supply is cut off. Z they move in a parabolic path towards the west under the influence of trade winds. Z different names: cyclones, Indian Ocean; hurricanes, Atlantic; typhoons, Western Pacific and South China Sea; Philippines Islands, Eastern China and Japan; and Willy Willies, Northwest Australia. Z favorable conditions for the formation: large sea surface with temperature 27 degrees Celsius. Presence of the Coriolis force, small variations in the vertical wind speed. A pre-existing weak low-pressure area or low-level cyclonic circulation. Upper divergence above the sea level system. In the South Atlantic and Southeastern Pacific regions and tropical latitudes, cyclones do not originate because of low sea surface temperatures. UPSC 2015. Type wind speed in km/h. Low pressure area, L, less than 31. Depression, D, 31 to 49. Deep depression, DD, 50 to 61. Cyclonic storm, CS, 62 to 88. Severe cyclonic storm, SCS, 89 to 118. Very severe cyclonic storm, VSCS, 119 to 165. Extremely severe cyclonic storm, ESCS, 166 to 220. Supercyclonic storm, SUBCS, 221 or more. Characteristic tropical cyclone, temperate cyclone. Origin, thermal origin, dynamic origin, Coriolis force, movement of air masses. Latitude 10 to 30 degrees N and S of the equator, 35 to 65 degrees N and S of the equator. More pronounced in northern hemisphere due to greater temperature. Contrast frontal system absent formation due to frontogenesis. 38 atmospheric circulation and weather systems. Formation forms at sea greater than 26 to 27 degrees Celsius, dissipates on land, can form on land in seas. Season seasonal, late summers August-October, irregular, fewer in summers, more in winters. Size limited to smaller area, 100 to 500 kilometers diameter, larger area, 300 to 2000 kilometers diameter. Shape elliptical, anvil-shaped inverted V middle latitude cyclones. Rainfall heavy but short-lasting, slow, continuous rainfall for days or weeks. Wind velocity much greater, 100 to 250 kilometers per hour, comparatively low, 30 to 150 kilometers per hour. Isobars, complete circles, steep pressure gradient, V-shaped, low pressure gradient. Lifetime lasts 1 week, lasts 2 to 3 weeks. Path east to west, trade winds west to east, westerlies, calm region at the center, calm region with no rainfall, no single region with inactive winds or rains. Driving force, energy from latent heat of condensation, energy depends on air mass densities. Influence of jet streams, relationship with upper level airflow, less clear, distinct relationship with upper level airflow, jet streams, Rossby waves. Clouds, few varieties, cumulonimbus, nimbostratus, variety of cloud development at various elevations. Occluded front clouds, influence on India affects both coasts. East coast more impacted, brings rains to northwest India, associated with western disturbances. VVV. Special cyclones. Z-twin cyclones cause equatorial Rossby waves. Characteristics: positive vorticity, counterclockwise and clockwise rotation. Favorable conditions: positive vorticity, air lifting, warm ocean, greater than 27 degrees Celsius, low wind shear. Development: starts as tall vortices, intensifies and moves westward. Z-Fujiwara effect. Definition: interaction between simultaneous tropical storms within 1,400 kilometers. Impact: alters track and intensity, can lead to merging. Z-bomb cyclone. Characteristics: mid-latitude storm, rapid intensification, greater than or equal to 24 MB in 24 hours. Genesis: clash of warm and cold air masses. Areas: common on the U.S. coast, colder months. Thunderstorms and tornadoes. Thunderstorms and tornadoes are brief but highly destructive, typically limited to a small area. Z thunderstorms, a well-grown cumulonimbus cloud producing thunder and lightning. Caused by intense convection during hot, humid conditions. Short duration, occurring over a small area, violent in nature. When these clouds reach altitudes with sub-zero temperatures, hailstones form and fall as hailstorms. In cases of limited moisture, dust storms are created. Z tornadoes. Sometimes severe thunderstorms generate a spiraling wind with very low pressure at the center that descends like the trunk of an elephant, causing massive destruction on its way, generally occur in middle latitudes. Tornadoes over the sea are called waterspouts. Polar vortex. Polar vortex is a large area of low pressure and cold air surrounding both of the Earth's poles. It always exists near the poles but weakens in summer and strengthens in winter. It is counterclockwise flow of air that helps keep the colder air near the poles. It is usually contained above the poles by the polar front jet streams. In winters, the vortex becomes stronger and bigger in extent, and the polar front jets also shift towards the equator. As a result, a part of the polar vortex may split and intrude into the mid-latitudes, called polar outbreak, bringing extremely cold weather there. E.g., large outbreaks of Arctic air in the United States.